Continue.
All right. Okay. Let's go to the next slide. So today we are going to look at the urinary system. Can you hear me, class?
Yes, sir.
All right. Good morning and welcome to today's lesson. So I'm glad that today we've met so that we can discuss the urinary system. Under urinary system, we're going to look at the organs of the urinary system. We also need to describe the structures and function of the kidneys. We should be able to describe the structure and functions of the ureters, as well as the structure and functions of the bladder, as well as the physiology of nutrition. Next. So like I've said, this is urinary system. So the urinary system, it is one of the major excretory systems of the body. The principal function of the urinary system is to maintain the volume and composition of body fluids within normal limits. So the body fluids which are found inside the body are regulated through the urinary system, which acts like an excretory organ, as we're going to see as we progress with our lesson. Next slide. One aspect of this function is to get rid of the body waste products that accumulates as a result of cellular metabolism, and because of this, it is sometimes referred as the excretory organ. So the urinary system is described as excretory organ or excretory system because it excretes some waste products that accumulates inside the body coming from cellular metabolism. Next. Next slide.
Yes, continue.
So although the urinary system has a major role in excretion, other organs contribute to the excretory function. So we're saying despite the urinary system being the major organ that plays a role in as far as excretion of body weights are concerned, other organs as well does this function. So these organs include the lungs in the respiratory system, extract some waste products such as carbon dioxide and oxygen. Next. So saying such as this organs such as the lungs, which excrete carbon dioxide and water. So we are saying apart from the urinary system, the kidneys being a major role playing excretion of body weights, other organs such as lungs, they also contribute in what it does. And the lungs get rid of carbon dioxide and water. The skin is another excretory organ that reads the body waste through the sweat glands. So we can also see that in the skin, it is also contributing in getting rid of the waste products from the body through the sweat glands. The liver and intestines excrete bile pigments that results from the destruction of hemoglobin. So the liver also comes in playing a law of excretion by removing bile that comes as a product of destruction of hemoglobin or red blood cells. The major task of excretion still belongs to the urinary system. If it fails, the other organs cannot take over and compensate adequately. So this simply means that despite these other organs coming in to play various laws of excreting waste products from the body, the major law of excreting various waste from the body belongs to the kidney, or it is done by the kidney. And this is the reason why when the kidneys fails, someone has acute renal failure. When the kidney fails, what the kidneys does by removing waste products from the body, it cannot be done by other excretory organs which we've mentioned, like the skin, the liver, the lungs. They just do a very small percentage of waste excretion from the body, but 75 or 80% of waste products excretion from the body is done by the kidney. Hence, it is the major excretory organ of the body. Next. So the urinary system maintains appropriate fluid volume by regulating the amount of water and that is excreted in the urine. So like we said in the beginning, say it maintains the fluid levels in the body. This is achieved through what is coming out in the urine. We understand that urine is in form of water. So when the body is in need of more water, you may see that the amount of urine that is passed in 24 hours is reduced. Then when you have a lot of water in your body, the body will try to get rid as much as it can so that there is a balance of water in the body. As you know that if there is so much water in the body, it may also contribute to the rise of your BP, that is hypertension. In other aspects of its functions includes regulating the concentration of various electrolytes in the body fluids and maintaining normal pH of the blood. So this excretory organ also ensures that it also regulates the concentration of various electrolytes in the body. When the electrolytes in the body they've been regulated, it ensures that the pH of the blood is maintained. When the pH of the blood is not maintained, a lot of cells may die because the pH is not optimum for them. Next. In addition to maintaining homeostasis in the body, the urinary system controls red blood cell production by excreting the hormone erythropoietin. So this erythropoietin hormone is the hormone that stimulates the production of red blood cells in the bone. So this is maintained also by the urinary system because the excretion of this hormone also depends on the levels of blood which person is having. The urinary system also plays a role in maintaining normal blood pressure by excreting the enzyme renin. Like I said, that if fluids haven't been well regulated in the body, it will contribute in the rise of fluid circulating in the blood circulation. As a result, someone may present with the high blood pressure. And this is the reason as to why in most cases, you may find that drugs like furosemide or Lasix is given to improve urine excretion so that there is maintenance of fluids circulating in the circulation to reduce blood pressure. Next. Now let us look at the organs of urinary system. What are the organs that makes up the urinary system? Anyone to come in? Clara. So the urinary system consists of the kidneys, the ureters, urinary bladder, and the urethra. The urinary system consists of the kidneys, ureters, urinary bladder, and the urethra. So these organs, which we've mentioned about 4 of them, together they come up to make the urinary system. The kidneys form the urine and account for the other function attributed to the urinary system. So the kidneys, which are part of the urinary system, their main function is to form urine and other functions that we will try to learn later on as we go into detail of our discussion. The ureters carry the urine away from the kidneys to the urinary bladder, which is a temporary reservoir for the urine. So the ureters are tubes, one on the left and one on the right. So they transport or they carry urine from the kidneys, where it's being produced, to the bladder, where urine is temporarily stored before it can be nutrited outside. Next. So this diagram is trying to show us the components of urinary system, which we already mentioned. That is the 2 kidneys, which you can see from here. We have the ureters. This is the left ureter, and this is the right ureter. We also have the bladder. Then the last one is the urethra. The last one is the urethra. So this diagram is just trying to remind us the organs that constitutes or forms the urinary system. Next. So the urethra is a tubular structure that carries the urine from the urinary bladder to the outside world, just like I said. The kidney forms urine, which I mentioned earlier on. The bladder is a reservoir for urine storage. So once urine has been formed by the kidneys, the ureters will have to carry the urine from the kidneys to the bladder, where it's being stored while waiting to be nutrited or passed to the outside world. The ureters transport urine from the kidneys to the bladder for storage before it can be excreted by the urethra. Next. So structure and function of the kidneys. Let us look at structure and functions of the kidneys. The kidneys are the primary organs of the urinary system. So when we are discussing of the urinary system, one of the cardinal things that you have to think of is the kidneys. Without the kidneys, then there's no need for us to be talking of the urinary system. The kidneys are the organs that filter the blood, remove the waste, and excrete the waste in the urine. So the principal function that the kidneys does is to filter the blood, to remove the waste, and excrete them through urine. we are talking of nitrogenous weights. The urea, when they're in high levels, they have to be excreted. They are the organs that perform the functions of the urinary system. Just like I said, when we are talking of the urinary system, there is nowhere we can never think of mentioning the kidneys, because these are the primary organs uh, that forms the urinary system. The other components are accessory structures to eliminate urine from the body. So we are saying these other organs that we mentioned, they're just trying to help to get rid of urine that has already been formed by the kidneys. Like for instance, when the urine has been formed by the kidneys, we will see that the ureters, they need to transport that urine which has been formed to the bladder. Then the bladder will store that urine while waiting for it to be excreted. As a result, we are describing the ureters, the bladder, and the urethra as accessory structures, but the kidneys themselves are the primary organs of the urinary system. Next. So the paired organs are located between the 12th thoracic and 3rd lumbar vertebrae, one on each side of the vertebral column. I explained earlier on to say the kidneys are located on both sides. There is right kidney and the left kidney. So these are found between the 12th thoracic, between the 12th thoracic vertebrae as well as the 3rd lumbar vertebrae. We are talking of the vertebral columns which are part of the spinal cord. So when we're talking of the 12th thoracic vertebrae, we're talking of the last T12, as you know that we have the C7, C12, as well as the C4 and C5. So from the various numbers which we have on the vertebral column, we're just interested in the T12 and the C5, where we find the location of these paired kidneys. The right kidney usually is slightly lower than the left because the liver presses it downward. So structurally, we are saying the right kidney is a bit lower as compared to the left kidney because of the liver, which is found superiorly to it. And that explains as the reason why it is found a bit lower as compared to the left kidney. The kidneys protected by the lower lids lie in shallow depressions against the posterior abdominal wall and behind the peritoneum. So these kidneys which we're discussing, which makes up the urinary system, they are protected by the lids as well as the abdominal wall behind the peritoneum. Next. So from the description, we can see that the kidneys, they are retroperitoneal. They are retroperitoneal. They are found on the parietal abdominal organs, just like we mentioned earlier on the previous slide. So the description that we can say to the location of the kidneys, it simply means that they are retroperitoneal, located in the abdomen. Then each kidney is held by a connective tissue called renal fascia, and it is surrounded by a thick layer of adipose tissue called perineal fat, which helps to protect it. So we are still explaining on the protection. Like we said, the kidneys are quite delicate because of the law that they pray. And it is very important that the kidneys should be protected by, it is very important that the kidney should be protected all the times. And this is the reason as to why we mentioned that we have the lower lips which offer protection, as well as when you look at the abdomen, they are found at the back. They are found at the back. And apart from that, we are saying the adipose tissue and the renal fat, all these, the thick layer adipose tissue offers much protection to the kidneys so that they are not easily damaged at all course of times. A tough fibrous connective tissue called the renal capsule closely envelopes each kidney and provides support for the soft tissue that is inside. So actually, when you you try to recall how the kidney looks like from the animals, from the kidneys of animals that we normally buy from various butcheries, you find that before you arrive at the actual kidneys, outside you are going to find that the kidney is encapsulated with a connective tissue. So this connective tissue offers protection to the kidney. If something comes in to injure the kidney, let's say trauma, the connective tissue may offer support before the kidney is damaged. Because if you look at the fibrous tissue, it is slippery in nature, which offers protection to the kidneys. Next. So in adult, each kidney is approximately 3 centimeters thick, 6 centimeters wide, and 12 centimeters long. That is how big a kidney is supposed to look like in an adult. So this is very important as medical personnel. When someone comes with infection of the kidneys, when you do some ultrasound scan, X-ray scan, or CT scan of these kidneys, if the kidney is looking bigger than these parameters which were being told, it simply means that the kidney is having an infection. It is undergoing inflammation because of an infection that it is having. So it is very important that you need to know how a normal kidney measures like in adults, which we are being told, say it is 3 centimeters thick, 6 centimeters wide, and 12 centimeters long. If you don't know what are centimeters, look for a mathematics set, and there is a small set, a small rule that can show you how long is 12 centimeters, about this size. It is roughly being shaped with an indentation called the helium on the medial side. So the structure of the kidney is being shaped. It resembles the shape of a bean, coming from beans. So if you look at the shape of the bean, there is a place where it has a depression, and that depression is what we describe it as a helium on the medial side. And this place, the helium, it's where it provides an attachment for various blood vessels. Talk, for instance, the renal artery, the renal vein, they enter the kidney through this breast site, which we call it as a helium. So the helium leads to a large cavity called the renal sinus within the kidney. The ureter and renal vein leave the kidney, and the renal artery enters the kidney at the helium, like I've said already. Next. So now let us look at the organs which are associated with the kidneys. The organs which are associated with the kidneys. So when we talk of organs associated with the kidneys, we mean organs which are closely found to the kidneys. So as the kidneys lie on either side of the vertebral column, each is associated with a different group of structures. So let us look at the right kidney, because we have two kidneys, and it's obvious that the structures which are closer to the right kidneys, they'll be different with structures which are closer to the left kidney. So right kidney superiorly, it is associated with the right adrenal glands. Superiorly, it is associated with the right adrenal glands. Then anteriorly, going to the front, we have the right lobe of the liver, the duodenum, and hepatic pressure of the colon. So all these, we find them anteriorly of the right kidney. Then posteriorly, as you're going to the back, we have the diaphragm and the muscles of the posterior abdominal wall. So these are some of the structures associated with the right kidney. Next. Then the left kidney, superiorly we have the adrenal glands, and this is true because when you look at these kidneys, both of them, they have adrenal glands on top of them. So this is the reason as to why you can see that both of these kidneys, they are having adrenal glands. We'll come to learn later what are the functions of the adrenal glands, but for this session, we are just interested to know what is found on top of the kidney, which is the adrenal gland. Then anteriorly of the left kidneys, we have the spleen, the stomach, the pancreas, duodenum, as well as the splenic pressure of the colon. So you find that the splenic pressure of the colon is also found on both sides because it is found in between these two kidneys. Then posteriorly, we have the diaphragm and muscles of the posterior abdominal wall. The diaphragm and the muscles of the posterior abdominal wall. Next. So now let us look at the gross structure of the kidney. The gross structure of the kidney. So there are three areas of tissue which can be distinguished when a longitudinal section of the kidney is viewed with the naked eye. So when we mean the gross structure of the kidney, we mean structures that can be seen with your eyes. When you look at the kidney that has been cut, what are some of the structures that you can see? Hence the word gross structure. So when you have a look at the kidney that has been cut across, you'll be able to see a fibrous capsule. You'll be able to see a fibrous capsule surrounding the kidney. You'll be able to see the fibrous capsule surrounding the kidney. Then you also be able to see the cortex, a reddish brown layer of tissue immediate below the capsule and outside the pyramids. So when we look at the cross section of the kidney, you are going to see where you can find the fibrous capsule as well as the cortex. I'm going to show you these structures. Then you can also see the medulla. The medulla, which is the innermost layer consisting of a pale conical shaped striations and the renal filament. So when you look at the kidney that has been cut using your eyes, these are some of the things that you can see without the need of using a microscope. Next. Also, the helium is the concave medial border of the kidney, where the renal blood and the lymph vessels, the ureter and nerves enter, which I explained earlier on. You'll be also able to see the helium once the kidney is cut. Then the renal pelvis is the funnel shaped structure which acts as a receptacle for the urine formed by the kidney. There's a number of distal branches called calyxes, each of which surrounds the apex of a renal pyramid. So even these structures, you can as well see them when the kidney is cut. When the kidney is cut, you'll be able to see them. We go to the next slide. So urine formed in the kidney passes through a papillary at the apex of the pyramid into the minor calyx, then into a major calyx before passing through the pelvis into the ureter. So we're saying when the urine has been formed in the kidney, it has to pass through the structure called the papilla, which is at the apex of the pyramid into the minor calyx. From the minor calyx, it has to go to the major calyx, where urine has to start collecting. So when the major calyx has been filled with urine, then you find that it has to go into the pelvis, where the ureters starts to originate and start draining the urine to the urinary bladder. The walls of the pelvis contains smooth muscles and aligned with the transitional epithelium. The walls of the pelvis contain smooth muscle and aligned with transitional epithelium. This is the region where the ureters begin, so that they can carry the urine that has been collecting in the major calyx, so that urine can be transported to the urinary bladder, where it can be stored for a long period of time. Remember, once urine has been formed in the kidneys, it is not supposed to be stored in the kidneys, but it's supposed to be stored in the urinary bladder. Next slide. So peristalsis of the muscles, of the smooth muscles originating in the pacemaker cells in the walls of the calyces, propels urine through the pelvic and ureters to the bladder. So we're saying these muscles, which are found in the calyxes of the kidneys, they help in the pushing of urine through the ureters to the bladder, so that urine can be excreted, just like with blood. When the arteries are pulsating, they also help to push blood in the blood vessels, so that blood in the blood vessels can be moving. But in the urinary system, we're saying these muscles, they help in the pushing of